In this video, we're going to talk about real-life examples, real-world examples of key features of the linear function. And remember, in a linear function, the equation for any linear function is just y is equal to mx plus b, where your m is your slope, and your b is what we call our y-intercept. Now, in a real-life situation, then, we can think of the slope as what we refer to as the average rate of change. And in order to be an average rate of change, something has to be constantly doing it over a period of time, which is why a line is a nice thing to talk about slope, because if you look at this graph here, this line is increasing over the same amount over time. And then we talk about a y-intercept. Well, our y-intercept is what we're going to call our starting point, or in some cases you'll see it called the initial value. And so when we talk about a line, what we do is we're going to identify the slope and the y-intercept, and we also want to talk about the domain and the range. The domain is the set of all possible x values, and the range is the set of all possible y values. So our domain here, we look at this particular example, it says, to rent a bike, Max pays a flat rate plus an hourly rental fee. The equation C is equal to $2.50 plus $5 gives the amount he pays C based on the number of hours T he uses the bike. The graph below models the situation. In this particular case, we can see that the equation is y is equal to, here you have your slope, which is basically $2.50, plus your slope, plus the amount of time he actually rides that bike for, T. So it costs him $2.50 for every hour he rides the bike, plus he has to pay a flat rate, and that flat rate is the starting amount, which in this case is 5. So if you look here, notice the y-intercept is sitting at 5. That is his initial value. This is the initial starting point. And then he's paying this constant rate over a period of time. And this constant rate is going to be $2.50. So for every hour that he uses the bike, he pays $2.50 for that particular hour. So if you notice here, after 2 hours, he has paid $5. After 4 hours, he's paid $10. And so look what's happening. If you start here at the initial value of 5, and you pay another 5, you're going to be at 10. Pay another 5, you're going to be at 15. So he's increasing by that $2.50 per hour right there. So we know that the initial value here is $5, and the constant rate, or the amount he's paying per hour, is $2.50. And so we want to find, the next thing we want to identify the domain and the range. Well, the domain here is your time. And so however long he keeps his bike for him, he has to start at 0 hours, and then from 0 all the way up to when he turns it back in. In this particular case, the graph only goes up to 11, but in theory, it could go on for an infinite amount of time based off of this. But let's say he only uses it for a day. So the most he could do it in a day would be 24 hours before it's recycled back over. And then the range then is based off the amount of hours he uses that bike for. So depending on how many hours he's going to use the bike for, that's going to be our cost. It's going to determine our final cost. And the cost is always going to start at $5. The minimum he can pay is $5. In order to actually get the bike, he has to pay $5. So we're going to start at 5. So our domain, let's do our domain first. The domain says he has to start at 0 and technically go up to, on a time, infinity. So we say that x has to be greater than or equal to 0. And then the range, so here's your domain value. That's the domain. And your range is going to be, well, he has to pay $5 as the minimum. And then he can go up to however long he rides it for. So, but that can go up to infinity as well. So the range here is just going to be your y variable has to be greater than or equal to, remember, his starting value is 5. He can't go below 5. That's his floor. He has to go above it. So here's how we interpret the real life meaning of these particular values: the slope, the y-intercept, the domain, and the range for a linear function.